Hello again. We'll continue with the documentation for the GitHub Actions. Yeah, we're gonna do the boring stuff, but before we go to the second and the third topic, which is continuous integration and continuous development, let's recap what we have learned previously. So let me switch the recording type and yeah, let's draw it out. So, hi. So let's draw out the most important things that we learned last time. And so we will have an event which will trigger a workflow. Can I have like... Okay, I don't see any shapes here, but anyways, let's draw a workflow as a square. That will be our workflow, and in each workflow we will have a job which will have some automated steps to do. And each of the job will be run on a separate runner. And we can run those jobs either in parallel. Let's write just job 2, or we can make that one job is required by the other job. And our workflow is nothing more than an automated task that can be run on an event, which can be either a push event or any other event in GitHub. So that will help us with our code integration, testing, and deployment. Okay, so let's continue with reading the documentation. We'll have the article 2 and 3 for today, and let's read what the official documentation for the GitHub Actions. Okay, about continuous integration. Continuous integration is a software practice that requires frequently committing code to a shared repository. Committing code more often detects errors more sooner and reduces the amount of code a developer needs to debug when finding the source of an error. Frequent code updates also make it easier to merge changes from different members of a software development team. This is great for developers who can spend more time writing code and less time debugging errors or resolving merge conflicts. So yeah, in general, it's a practice to provide smaller changes which can be tested more often, and this will allow us to detect either any regression in our software or system sooner than later. Yeah, the bigger commit you make to a repository, the more code you have to check for eventual conflicts or errors or bugs. So for example, running some tests on commit to a branch will help you prevent from pushing some of those errors or improper style formatting to your repository. Okay, the second part, when you commit code to your repository, you can continuously build and test the code, which we told, to make sure that the commit doesn't introduce errors. Your test can include code linters, which check style formatting, security checks, code coverage, functional tests, and other custom checks. Building and testing your code requires a server. You can build and test updates locally before pushing code to a repository. Or you can use a CI server that checks for new code commits in repository. So again, we have this summary for what we can use: the continuous integration for style checks in our code, security checks. We can use test coverage library to check how many of our code is not tested correctly. If we want to have like 100% tested coverage, or that's our requirement. So yeah. What is more here about continuous integration using GitHub Actions? CI using GitHub Actions offers workflows that can build the code in your repository and run your tests. Workflows can run on GitHub host virtual machines or on machines that you host yourself. And for more information, we have more documentation under the links, but we will go do it further down the road, not today. You can configure your CI workflow to run when a GitHub event occurs, for example, when new code is pushed to your repository on a set schedule, or when an external event occurs using the repository dispatch webhook. So yeah, that's something I mentioned a bit earlier, but in general, we can run tests of our code when our code is pushed. We can run a schedule. So that will be, for example, we could create a GitHub action to create a backup every day or every 12 hours of some of our content or code or anything else in our system that needs to have a backup. Or when an external event occurs, so we can dispatch an event that will trigger our GitHub actions. So that will be probably mostly used when you want to deploy your code to one of the environments. If you have integration or some pre-production environment or production, you can trigger it when needed. Okay, let's go further. GitHub runs your CI tests and provides the results of tests in the pull request, so you can see whether the change in your branch introduced an error. When all CI tests in a workflow pass, the changes you pushed are ready to be reviewed by the team member or merged. When a test fails, one of your changes may have caused the failure. So yep, and that's pretty self-explanatory. You can fail some jobs depending on test failures, and yeah, that will benefit us from not introducing any errors to the system. When you set up CI in your repository, GitHub analyzes the code in your repository and recommends CI workflow based on the language and framework in your repository. For example, if you use Node.js, GitHub will suggest a workflow template that installs your Node.js packages and runs your test. You can use the CI workflow template suggested by GitHub, customize the suggested workflow template, or create your own custom workflow file to run your CI tests. Okay, yeah, I guess that's self-explanatory. We are provided with some templates which we can then modify to our needs. In addition to helping you set up CI workflow for your project, you can use GitHub Actions to create workflows across the full software development lifecycle. For example, you can use Actions to deploy, package, or release your project. And again, more documentation under the linked files. I don't think that this requires any more comment on either GitHub server or our self-hosted server. We can define some actions that will be done, so automated tasks to do, and those can test, deploy, package, or release our project code. Workflow templates. GitHub offers CI workflow templates for a variety of languages and frameworks, and we have a link to Action Starter workflow repository. And if we go to this link, there's quite a lot of YAML files for many languages or frameworks. Maven build tool, that will be for Java Maven. Setup JDK 17, and we have a package build for PHP npm publish. Okay, so we have an action that will run the command CI test and CI clear install and npm test. So yeah, we can pick up any of those actions, create scripts in our npm or other builds tool, and just trigger them on our server. Okay, let's go back. Let's now read the definitions provided in the continuous deployment of this documentation. So you can create custom continuous deployment workflows directly in your GitHub repository with GitHub Actions. So let's read about the continuous deployment. So the definition provided in here: continuous deployment is the practice of using automation to publish and deploy software updates. As part of the typical CICD process, the code is automatically built and tested before deployment. Continuous deployment is often coupled with continuous integration. For more information about continuous integration, we can go a step back, probably. About continuous deployment using GitHub Actions. You can set up GitHub Actions workflow to deploy your software product. To verify that your product works as expected, your workflow can build the code in your repository and run your tests before deploying. And that's quite self-explanatory. It's the same as for the integration. You can run some tests on opening PR or committing something to repository, maybe opening an issue. So yes, that can also be done before deployment. So let's read it further. You can configure your CD workflow to run when an event occurs. For example, when new code is pushed to the default branch of your repository. Okay, yep. On a set schedule, manually, on when an external event occurs using the repository dispatch webhook. And again, more information on older events which will trigger workflows. We will also discuss this documentation further down the line. Okay, GitHub Actions provides features that give you more control over deployments. For example, you can use environments to require approval for a job to proceed, restrict which branches can trigger a workflow, or limit access to secrets. You can use concurrency to limit your CD pipeline to a maximum of 1 in progress deployment and 1 pending deployment. For more information about this, see the other documentation. Yeah, so it allows us for quite a lot of customization if we want to make sure that we don't run 2 deployments in parallel, because we would not know which code will be pushed first and which will be go second to our production environment, and that would probably cause many problems, maybe network problems or some connection or authentication, and yeah, we may probably broke our application if we're gonna send few files at the same times with the same names to the same server. So yeah, this can all be checked and configured. Using OpenID Connect to access cloud resources. If your GitHub Action workflow needs to access resources from cloud provider that suppose OpenID Connect, you can configure your workflows to authenticate directly to the cloud provider. This will let you stop storing this credential as long-lived secrets and provide other security benefits. Yeah, so OpenID Connect is a way to authenticate a user with not long-lived credentials or persistent credentials as we call them, but yeah, temporal tokens which will expire quite quickly. So that's a nice security feature. In case of those credentials will be leaked, the attacker or the hacker won't have access to the system longer than an hour or 2, depending on how long the credentials are valid. Okay, workflow templates and third-party action, GitHub, and again we have the page for templates which we visited for many frameworks and languages to be used. Okay, I guess this is enough for today, for this episode. We know that the continuous integration, when we talk about working on our code base, when multiple developers work on our code base, we need to integrate all the changes, the features, the bug fixes continuously, and the good practice would be to push smaller changes that will help us to debug the eventual bugs and problems and errors sooner with a lesser code to scan than deploying features that have a lot of code and yeah, may produce more errors, and that will be harder task to integrate those changes. So a good practice would be providing smaller chunks and test the smaller chunks continuously to our code repository. And for continuous deployment, what we have are code ready, the build process, test process, and the deploy process of build application allows us to also do it continuously and in an automated way, as machines are good in doing the automated stuff, repeated tasks, and make less mistakes than humans when doing a step-by-step instructions. Okay, so we'll be in next video, which will be somewhere on the screen. We'll be checking the quick start, and probably let's check it out. Yeah, we can copy this workflow and we will try to trigger it and write our first workflow and check some outputs, but that will be in the next video. Thank you for your time and see you there.